Okay, so today we are going to talk about object-oriented programming, but not in a boring way, not like oops means this, oops means that. No. I'm going to show you visually how code becomes messy, why oops exists, and how real software actually uses it. And by the end of this video, I promise you, you won't just memorize oops, you'll understand it. So let's start from zero. So object-oriented programming is not a language, it's not a framework, it's a way of thinking. It's basically a style of writing code so that it doesn't become a headache later. These four pillars: inheritance, polymorphism, encapsulation, abstraction. People memorize them, but memorizing doesn't help, understanding does. So first, let me show you the problem. Okay, now let's slow down here for a second. Okay, look at this. Imagine this is your project. Some code here, some code there, login, database, UI, email, everything is next. In the beginning, it feels okay. You're like, yeah, I know where everything is. But after 6 months, you open this code and you're scared. You don't know what will break if you do something. This is called spaghetti code. And this is why oops was created. Okay, now let's slow down here for a second because this part is very important. Look at these boxes on the screen. Each box is an object. This one is user. This one is product. This one is order. Now, what's inside these boxes? Inside every object, there are two things. Number one, data, and number two, actions. Data means information. User has a name, email. Product has a title, price. Order has a order ID, status. These are just values. Now second part, actions. Actions means what this thing can do. User can log in, user can log out, product can apply a discount, check stock, order can be cancelled, track. So an object is not just data, it's data plus behavior together. So data plus behavior in one place. Think about your phone. Your phone has data, contacts, photos. Your phone has actions, call, message, open apps. Everything is inside one device, not scattered. That's an object. Without objects, name is here, login code is there, email logic is somewhere else. So you waste brain power finding things. With objects, everything is together. That's why object make code calm. Now here's the problem. We don't want to create objects manually every time. That's where classes comes in. Okay, now focus here. This box is not a real user, it's just a design, it's a plan, it's like an instruction manual. Imagine a phone factory. Before making phones, they design one model, same size, same buttons, same screen. That design is the class. Then they produce 1 million phones. Those are objects. Same design, different copies. So in code, same thing happens. We write one class, inside it we define what data every user has, what actions every user can do. Every user has name, email, every user can log in. We write that once. Then we do new user. And one real user is created with its own memory, with its own values. So Alice is one object, Bob is another object, same structure, different data. Now imagine if you don't have classes, like you'll write this again and again, user code 1, user code 2, user code 3. Waste of time, more bugs. With class, one place to fix, one place to improve, everything updates. Class is equal to rule book, object is equal to player. So rule book doesn't play, players play. So class doesn't run, objects run. So now you see, OOPS didn't start with inheritance. It started with this, objects, classes. Everything is built on top. Okay, now this part, inheritance. This is where most people get confused. So don't worry if you don't get it instantly, that's normal. Let's start from real life. Suppose you have a company. In that company, you have employees. Some are normal employees, some are manager, some are admins. Now, all of them are employees, right? All of them have name, ID, salary, login access. So the question is, should I write this code 3 times? No, that's stupid. That's where inheritance comes. Employee manager, employee admin. Employee is parent, manager is child, admin is child. So here user is a parent class, admin is a child class, moderator is a child class. So child automatically gets everything from parent, like name, email, login. So you don't repeat code, you reuse brain power. Now here's the important part. Inheritance is not copy paste, it's connection. If parent changes, child changes. If company changes login rule, everyone gets it. But child can also add extra power. Admin can delete the user. Employees cannot. Moderator can ban the user. Employees cannot. So child is parent plus extra. Now listen carefully. Too much inheritance is dangerous. A to B, B to C, C to D, D to E. This becomes hell. Nobody understands where logic lives. That's why good devs keep it shallow. 2 to 3 levels max. So inheritance is about reuse, hierarchy, and discipline. Now this word sounds scary, polymorphism, but the idea is simple. Same command, different behavior. You have remote control. You press on, TV turns on, AC turns on, fan turns on. Same button, different machine. That's polymorphism. Even in code, we call speak. Cat, dog says woof, cat says meow, bird says tweet. We just say speak and object decides. This is powerful because code becomes flexible. Tomorrow new animal comes, you don't change old code, it just works. Payment system, PayPal, card, all have pay. You don't care how, you care result. So polymorphism is equal to trust. You trust objects to do job. So good design is less if else. More polymorphism, less conditions. So polymorphism is about flexibility plus future proofing. Now this one is about safety, encapsulation. Let's talk about ATM. You insert a card, enter PIN, withdraw money. Do you see bank database? No. Do you touch server? No. You only see interface, buttons. That is encapsulation. Inside is complex, outside is simple. Without encapsulation, anyone can change balance, anyone can change password. That's dangerous, so we hide data. Private means stay inside. If someone wants change, they go through function. That function checks rules. You cannot set negative balance. Function stops you. Encapsulation is equal to control. You decide who touches what. So big companies survive because of this. Without it, so systems collapse. Encapsulation also helps teamwork. One dev works inside, other uses outside, so no conflict. So encapsulation is about security plus stability. Okay, now this one, abstraction. This is my favorite because this is how normal humans think. Let me ask you something. When you drive a car, do you think about fuel injection? No. Gear ratios? No. You just think start, go, stop. That's it. That's abstraction. Top layer simple, bottom layer complex. User only sees stock. We hide thousands of lines of code. We expose 3 to 4 functions. You use Instagram. Do you think about servers, databases, CDNs? No, you just scroll. That's abstraction. When you call fetch, do you see TCP, DNS, packets? No, JS hides it. So abstraction saves brain power. If everything was visible, you'll go mad. So good software equals to hide complexity. So bad abstraction is dangerous. If abstraction is wrong, you can't extend system. So designing abstraction is art. So abstraction is all about simplicity on surface, power underneath. Okay, now let's connect everything because till now this feels theoretical. Let's build a real system. Amazon, Flipkart, Myntra. User clicks buy. First user object, then order object, then payment object, then delivery object. All are classes. Inheritance, payment, credit card, payment. For polymorphism, calculate shipping, different rates. Abstraction, user clicks buy 100 hidden operations. Encapsulation, private card number, public process payment. That's good design. So one team works on the payment, one on delivery, one on UI. So OOPS makes this possible. Without OOPS, system collapse. So every big app you use runs on these ideas. Now real talk. OOPS can destroy your code. Yes, destroy. So mistake 1. Deep inheritance. Class, 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 class. Nobody knows where bug is. So fix one place, break 5 places. Second mistake, God object. One class, 500 methods. It controls everything. So if it breaks, system dies. Mistake 3, over engineering. People create 20 class for printing hello. So don't do that. Mistake 4, wrong abstraction. Bad abstraction equals to prison. You get stuck. So simple rules, small changes, clear purpose. Code should be boring. Boring is good. Okay, so let's wrap this up. So if you remember only this, like inheritance, reuse with discipline, polymorphism, one interface, many behaviors, encapsulation, protect your data, abstraction, hide complexity. Together they create maintainable systems. So don't just memorize, practice. And that's it for the video. I hope this made OOPS clear for you. If it helped, make sure to subscribe. I'll bring more visual tech videos like this. See you in the next one.